Hello, welcome back to LIVENODING. In this episode, I want to try to re-emulate this video explaining how you can split and subdivide multiple faces. And in this example by Ilir Beqiri using geometry nodes, it is actually explained really well. It's a really hard, really difficult concept never if you never actually done this using this method, but I think I can re-explain this probably easier using SVerchok, even though it's already like super clear here. So what Ilir Beqiri does in this example, I think if you watch from 1 to 15 minutes, he tried to explain, I think, how you can break a plane into 4 and then look at the index using geometry nodes. And some parts actually is a little bit convoluted, but this is also really important if you watch this one first. But I'll try to explain it using SVerchok. With SVerchok, it's a kind of similar, and there's a bit of shortcuts with SVerchok because you have things like split edges, and SVerchok also have like split faces. So if you wanna see some documentation, I'll show you. Okay, split edges. There's split edges and there's split faces. We're gonna be using split edges, and this function basically will perform split on multiple edges at the same time. There's a couple of examples. So what, in this case, what we are trying to do is really to make like some kind of like a Mondrian split, right? With Ilir Beqiri setup, you actually get the whole things, and yeah, you can actually download the blend files from his Patreon. I will try to re-explain using SVerchok. Anyway, maybe it's kind of unnecessary, but if I show you, if you watch this Ilir Beqiri once and you don't understand, this method probably will explain it easier. Maybe it's helpful, I don't know. Let's take a look. So with this method, I actually start with the plane, and I just split the edges right away. In this case, I have 9 faces because I have 4x4 plane. So what's happening here? It's like this. I started with the plane, and then I split it into 9. And yeah, 9 faces, and then I use split edges, and I split it randomly on every vertical and every horizontal edges. Okay, so this actually does the job, but it doesn't create an edge right away. So you need to, what you need to do is just to connect the 2 of the 4 new vertices whenever it's being created. So after the split edges, I use the polygon boom and separating each and every face, and then I smooth the vertices. This just to make it easier because all the faces will be separated, and each of the face will have new index that's being generated. So the original index is actually this one, 0, 0, 2, 4, 6 for each one of them. And with SVerchok, all you need to do is to actually connect the dots between 1, 5, and 3, 7. So 1, 5, and 3, 7 is what we need to connect, And in this case, because we have 9 faces, so this is the index of the edges that I try to connect. I just join them, and then I use list repeater 9 times, and then I join it with the original edges data, and then I connect the index that way, and I just use intersect edges and fill holes to have this setup. So if I get rid of all the smoothing, what I get is this split of faces, like instantly splitting. And this is the random number where we put the split on each and every faces. So it's maybe I think I should try to just split a single face to make sure we understand. Okay, let's start this again. Okay, split. SVerchok nodes. Start with the grid. We have split edges. We actually have split mesh elements, which kind of like doing what Polygon Boom does, but it's a little bit more robust. This will split all the elements, whether you want vertices or edges, you know. Take a look at that maybe at some point. I want to show you the whole process anyway. So this, let's center this and then change the orientations. So it's just a single plane, and I want to split the edges. So this is already doing the split at the moment. If you go to edit mode, you can see the edges is being split. Okay. And I could actually mask the edge quite easily. It's if we are, but for now we're gonna try to connect the dot first. Let's use index viewer. So I want to see the index of this. It's super tiny there, but it's actually there. Gonna make it bigger. Okay. So we have a single plane. I already split it magically using split edges. And yeah, we have the original vertices 0, 1, 2, 3, and then the new one 4, 5, 6, 7, right? 4, 5, 6, 7. We need a way to add and connect the dots there using edge indices. So if you look at the stethoscope, look at the edges. Okay, this is all the edges that we currently have on this object. So we already split the edges. We actually have a multiple splitter, like we have the mirror, which is pretty cool. We have also multiple cut for edges. That's also super cool. For now, just use simple. Okay, we have this, right? Now I just want to connect the dots. How do we do that? Let's use input. Okay, list input. List length will be 2. Get another one. We're gonna connect 4 to 5 and 6 to 7. We can just join. 4, 5, 6, 7. Okay, this is the thing that's gonna connect this guy over there. And I will just use another list join. It's gonna connect the edges data. Take a look at the result there. I think it seems to have the right data. All we need to do is to connect these two edges. And hopefully, okay, let's see if the data is correct. All right, okay, I think I did something wrong there. Let me check. Study split. Try to find the one I did last night, and okay, I think this is the one. Plane, split edges. Okay, in this one I actually use index to mask the edges that I want to split, and I did use the list input and list join. So list join level 1, list join level 2. I have this factor that to control the splitter. Index viewer. Let's show you. So that's the index. So this is actually the closest to example by Ilir Beqiri. Just a kind of simpler this way. I think I'm splitting the face using this splitter that's horizontal, and this is a plane, and we have split edges, and this is the factor where we want to split it, right? We want to split the face. So this is the index that we connect, which is 4 and 5. list join, and then we wrap it, and then use list join again to connect the two. So wrap 1, and this is 2, and we simply fill the hole. After we if we have 2 lines, we need to intersect the lines. So let's take a look again. One, this we need to wrap. This is gonna be 2. Okay, that's the setup I want. Okay, 4, 5 get connected, 6, 7. So it's like an X. We have this vector, kind of like a Mondrian thing. And then all we need to do now is to use intersect edges. So it's going to be intersecting, and we have a point there. We can use fill hole to get the Mondrian thing. So that's the factor. If we use, so that's the whole setup. If you use random value, random number of float, we have, okay, let's make it 4. If you randomize the seed, you can see as long the cut and the number of index is to say the same, we can split and cut this plane ever so easily, right? That's actually the whole thing. It's a little bit difficult concept to grasp. And then what I want to do now is just to use a loop. I mean, I will have to make another video for this, because SVerchok loop in and loop out is slightly different, but I believe we can perform this to multiple phases at once, like geometry nodes. Maybe geometry nodes will do it faster, and then what Ilir Beqiri showing you is already complete. It's like a key ED, right? Quad etat demonstratum. You don't need to explain it again. I think this is already perfect, and it's also using recursive, etc. SVerchok one is a little bit funny sometimes. If you want to make multiple split on a simple plane anyway, SVerchok can already do this. SVerchok is a little bit weird in that way. So if a simple plane, center it. There's a multiple way to procedurally generate plane in SVerchok, and we can do a split, right? What if you want to have more control on the splitter? You can do this. The step. I think this will actually do the job. It's just a little bit different, you know, see? So you can split the plane like that. We can also split the plane vertically. Split it into 2. You have like a kind of like a Mondrian thing. I think we need to keep this simple. That's a step. I'm using random number. Actually, maybe range number is what we need. But we can do like lots of split. Pretty easily, and then you can randomize the color, but it's not really Mondrian. What we really want, of course, like a oh, okay, I cannot create this pencil. Right. We really want it. We have a face, and we're able to split it that way, and then another split, and a smaller split, just like that. It's a Mondrian thing, but it's like a recursive split and subdivisions. If you dig through SVerchok example, I think there's already example like this. I actually made 2 videos about Mondrian in the past. Right, simple Mondrian art. Yeah, I've done this in the past. Just re-explain it today, and it seems a bit complicated, a little bit more complicated, but it's actually supposed to be simpler. Okay, split X. Split H study. Trying to find that Mondrian example. I believe it could be okay. This is the old setup. A lot of nodes has been depreciated. It's plain grid. As viewer, so random number gets inside the step, just like we saw earlier. So plane being split already, and we can pipe this into vertex color for the face. We want random color for the face, and all we need to do is apply the material. Plug this into the color, and we have hopefully random color. Yeah, that's exactly it. It's simpler, not exactly Mondrian. We need to do like a recursive subdivisions, and then it's completed. But it's a quick way to split a plane into this colorful looking windows, right? Like Mondrian. But if we get back to the first original example, I mean, let's go study split. This is what you need to understand first. Simple plane, split the edges. We can randomize the points where we split the edges, and then we connect the dots using this method, which is slightly convoluted, but I think the list in SVerchok is really just too powerful. And with just the list, we can create a new edges indices to connect the dots, and then we can intersect the edges and fill the holes. It's much simpler in that way in terms of working with topology, compared to, I mean, the Ilir Beqiri one is actually, you need to watch this video anyway to understand how you can look at the components and index of geometry nodes, and then have some kind of algorithm pattern. With SVerchok, you connect the dots, it's much easier. With this one, it's algorithm that's dealing with indices. This is the right way to do it anyway. And then you get a way to split, and then you can, you know, recursively doing that multiple times using loop, and then you get the proper Mondrian with the color, primary color. Yeah, it's complex things. Something like algorithm like this definitely can be explained as well using processing. I think in the future we're gonna use AI to explain it even easier. You know, like the algorithm, what's actually happening horizontally or vertically with the SVerchok things. This, I think, probably the simplest way to explain the whole thing. So split, if you want to connect the dots, if we split this more times, so I split it multiple times, for example, I could connect the dots easily as well. Here we have 6, 7. Let's say if I want to connect this 8 and 5, right? And I want to connect, okay, let's so we have random, we have cut, but we have too many split. Let's reduce this. Let's say I want to connect 6 and 5, 4 and 7, 9 and 13, 8 and 12 maybe. Yeah, okay. We have the X and the, it's kind of interesting, I think. I don't know why we have overlap there. Anyhow, with SVerchok, it's a little bit like a spider web. If we have, and we are dealing with vertices, edges, and faces at all the time, and usually vertices and edges is all what you need, and then you simply fill the whole faces using algorithm. In this case, we just use fill holes. It's a simple flat planes anyway, and we are connecting the dots using this way manually. And but even this part can use algorithm. There's so many nodes in SVerchok. I think one of them can actually just do the job of the edge split and connecting the dots, you know. So it's gonna simplify the method, and then once you understand that, you can just loop in and loop out to recursively does this on every faces. Can be pretty robust. Maybe in another video I'll explain it even easier than this one. So SVerchok has a lot of shortcut nodes that practically does the same job as geometry nodes, but if you can do it inside geometry nodes like this one, this is also will work, but just the nodes sometimes super complicated to create because it's kind of low level. SVerchok kind of do that, you know, easier to understand. So yeah, I don't know if this video ever be useful, but I think in the future the AI will try to learn this and explain it even better. Look at this video. you're gonna ask AI to look at this video and this video, and then try to use AI to explain the two, and then you're gonna have a full understanding, and perhaps let the AI to recreate the notes for you automatically. All right, so thanks again for tuning in, and I'll see you next time. Thank you. Bye.